So today we'll be covering chapter 5.x, which I call it 5.x because your book calls it 5.1, and they use accumulation of distance, but I think it's a little silly because it's super application-y and not geometric, and I don't think that's intuitive, personally. Okay? If you notice that this video quality is a little bit better, that's because I got my laptop working, so I don't have to record from two different rooms anymore, which is nice. So the question is, what happens if you underderive a function? Like, if you have like f of x is equal to like x to the 13th, right? And you derive it, that gives you f prime x is equal to 13x squared. Oh, to the 12th, right? What if you undo that process, right? So there's an example. If you have like f prime of x is equal to 7x to the 6th, right? And you undo that process, you might end up with like f of x is equal to x to the 7th, right? So the question is, if I give you f prime of x is equal to 5, right? What can f of x equal? I'll give you a second to think about it. I had already started lecturing, and I didn't hit record. So that's why some of the solutions are already on the board. Reasonably, right? Some of y'all might tell me, oh yeah, f of x is equal to 5x to the first, which is reasonable, because if you were to derive 5x to the first, you end up with 5. Okay, what if I raise you? It's actually 5x plus 48 pi. Both are valid, right? Because this is a constant, you derive it, it ends up here, right? We'll put a pause on this behavior for now. We'll come back to it later, all right? But just for your reference, this is technically a valid answer if I don't tell you any more information, okay? Now, the next question is, what does underdriving represent, right? Like, you know how f of x and f prime x, you take this, you derive it, you end up with this, right? What does going backwards do? Like, oh, f prime of 7 is equal to 13, which means at x equals, oopsies, at x equals 7, the slope of f of x is 13. Please don't forget that, right? Don't forget that the relationship between here and here is this is the original function, this is the derivative function, okay? Okay. But anyway, in that same way, right? If you undo a derivative, what does that mean? What does that original function mean relative to the derivative? I'll explain more in a second, all right? So let's say f prime of x is equal to 5, and we say f of x is equal to 5x. What I'm going to have you do is take the area of the rectangle made by f prime of x, so made by this line right here, where one corner is 0, 0, and another is 3, 0. Draw a picture, it'll make a lot of sense, okay? Sometimes you might hear it as, find the area under the curve bounded by this function and these two corners or these two values or whatever, okay? Or like the area of the function um blah 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 over the interval blah to blah, okay? That all means the same thing. Well, if you draw the picture, you should end up with like this, right? This is f prime of x is equal to 5. This is 0, 0, and 3, 0. So your x interval is 0 to 3. You know your height is 5. So, 3 times, times 5 is 15. So the area under f prime of x equals 5 over the interval 0 to 3 is 15. Okay. Now what I'm going to have you do is, do you remember that f of x function? I'm going to have you do me a favor. I'm going to have you say f of 3 equals what? You're going to solve that, okay? It should take all of like, by the time I finish like saying this sentence. Okay. Oh no, it's 15. Huh, interesting. fascinating even. Let's do a quick notation detour and we'll get into why this works. Okay. So if you underderive some function f of x, if you notice up until this point, I've been using going from f prime to f, right? But what if I just said, oh, f of x is equal to whatever, and I want you to go to underderive it? Uh, to do that, I'm going to have you call that big f of x or capital F of x, okay? Written like this. And to remind you of notation, okay, to remind you of notation, this is the relationship we have, okay? This is your original function, and if you derive it, you go this way, you get f prime. You derive it again, you get f double prime, okay? And if you underderive it, you get big f of x. I write in cursive, so I'm more likely to write it like this, but these two are the same thing, all right? This is just big f of x written in cursive because, okay? Cool. Now, let's take a look at another example. If you have f of x is equal to 6x, what could big f of x equal? Take a second and then yeah. Reasonably, right? You might tell me f of x is equal to 3x squared. Because you derive this, you get that. We're going to ignore the plus some constant business for now, okay? We'll ignore that for a second. Okay. Now what I'm going to have you do is take the area under f of x over the interval 0, actually inclusive, sorry, 0, comma 5. Draw a picture, it'll make a lot of sense. Okay. And remember that this is little f of x, okay? If you were to draw this guy out, you might get something that looks a little bit like this, where f of x is 6x. Let's just assume the slope here is 6, okay? Right. You're gonna go from 0. If you go from 0, that means you have like 0, comma 0 over here. You go to 5, let's say 5 lives here, right? Actually, that's a little far. Let's say 5 lives here. You go all the way up. Oh, look, it's a triangle. Ain't that nice? Go up to here. Well, if you want the coordinate, right, you're going to want to say this is 5, that's the x value, and then f of 5 is 30. So you know that the height of this triangle is 30. The width of this triangle is 5, right? How do you find the area of a triangle, I wonder? Surely it's not base times height divided by 2. 30 times 5 over 2, which is going to be 15 times 5, which should give me beep, 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 beep. Bro, that's 25 times 3, it's 75. 75. Okay, now let me ask you this. What is big F of 5 equal to? Surely it's not 3 times 5 squared, which is equal to 75. Huh, interesting. Okay. Now, obviously, right? Loosely speaking, no, actually, let's try that again. So, what can the underderivative possibly represent? Very loosely, okay? because there's a bit of nuance here that we'll get into at a later lecture. Well, hear me out. Loosely, it's the area under the curve. When we say under the curve, by the way, we mean like between like the function and the x-axis, okay? Not like infinitely down, okay? So loosely area under the curve over an interval. And we'll get into that over an interval part later, okay? Okay. Okay. Now my next question for you is, are all functions nice? Like, what if I give you like, oh, sine of x? You can't exactly, this is the first function we made a rectangle. The second function we made a triangle. Sine of x ain't that nice. But you know what shape is really nice? Just for like approximating purposes? Rectangles. But rectangles are nice. Okay? Rectangles are nice. Ready? Let's say I give you f of x is equal to x squared, and I want the area over 0 to 5. Okay, let's do a couple things so we can kind of be on the same page, right? One, we want rectangles. And two, we want 5 rectangles. If you want 5 rectangles and your interval is 0 to 5, what is the width of each rectangle? Surely it is, in fact, that easy, right? You go like that, that's 5, so 1, 2, 3, 4, 5. The total distance is 5, which means each rectangle should be, in fact, a width of 1. I won't always give you a width of 1, okay? But that's the idea. Okay, so draw your picture, sketch your curve, make your little rectangles, and tell me what the area is. Okay, I'll work this out in the meantime. Hit pause and then come back. Oh no. Okay, I'm gonna make some rectangles, and I recommend you do too. Let's see. I'm gonna say this is my first rectangle, and this is my second rectangle, and this is my third rectangle, and this is my last rectangle. Okay? For me personally, 1, 2, 3, 4. Oopsie, forgot my fifth one. Okay, how do I find the height of each piece? Well, it hits the curve, so I want f of 1, which is the height, times 1, which is the width, and this is f of 2 times 1, and this is f of 3 times 1, and this is f of 4 times 1, and this is f of 5 times 1. And that should give me, my function is x squared, right? Yeah. This is equal to 1. We'll use a different color. 4, 9, 16, 25. And that should give me 5. Goes like that. 14, 30, 55. Wait a minute. What if I broke my rectangle down a little bit differently? What if I said, oh, I want this to be the height of my rectangle, and this, and this, and this, and that, right? Well, if you do it like that, you end up with, let's see, f of 0, and f of 1, and f of 2, and f of 3, and f of 4. But that will give me 0, 1, 4, 9, 16, and that adds up to 14. This whole thing adds up to 30. Something ain't right. Let's take a look at this one more time. If we go here and we use the, let's see, if we go here and we use the, let's see, this is the left, right? We use the left endpoint, right? So left, 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 right? Get a slightly smaller number. If we go here, and we use the right endpoint, right, 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 get a bigger number. Okay, well, neither of them are wrong. I was just not being specific enough with you, is the problem. Okay? So, let me be very specific. In fact, let me be so specific, I give you a definition. Riemann sums. Okay? Let f of x be a continuous function, because you can't really do with discontinuous ones, right? Over the interval a comma c. And let n be the number of partitions or rectangles over a to c. We have a couple things, okay? If this is our total distance and we want this many rectangles, all you have to do is divide the distance of this by here to get the number of the rectangle width, right? I mean, that's exactly what we did here, right? So then you have 1 c minus, oopsies, c minus a over n is equal to your width of each rectangle, which we will call h, okay? Just so we don't confuse ourselves and we don't have to write this a bunch of times, okay? H is the width of each rectangle, and this is how you find it. 2, for the left Riemann, right? Left takes the lower points, right? The left Riemann will have the area is equal to the sum from the first rectangle to the nth rectangle, right? Because we have n of them, 1, 2, 3, 4, 5, all the way up to n, of the width times the height of each rectangle. How do you find the height? Well, if it's a left Riemann, you want to start with A, right? Start with A. So then you say f of A. But you're doing it as a bunch of partitions, right? So you know what? Let's do it a different way. A is equal to, the area is equal to the width of each rectangle times f of, well, it's a left Riemann, so f of A, right? F of A. Cool. But that's not all of them. You have to have all the rectangles. So then you have to have h times f of A plus, well, the next width, right? If you have the width, you get the next endpoint, right? F of A plus h. And then for the third rectangle, h times f of A plus 2h, right? Plus da 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 da. How many rectangles do you have? You have n rectangles. And we started counting at h equals 0. So instead of saying A plus 2n, you want f of A plus, not 2n, I'm so sorry. You have n rectangles, right? But you started counting at the 0th endpoint. You see what I'm saying? So instead of saying you have f of A plus n times h, right? You want n minus 1 times h, okay? Because this is the first rectangle, even though it's 0 times h. You see? So you have h times f of A plus n minus 1 times h, okay? That's a lot to write. So we can write this as the sum of k equals 1, sorry, k equals 0, all the way up to n minus 1, right? Because you count 0, 1, 2, da 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 da, n minus 1, and that'll give you n rectangles because you start counting at 0. I know that's some CS behavior, I'm sorry, right? You have this. So the sum of all these, h times f of A plus k h. Easy, right? You're saying this is plus 0 width, plus 1 width, all the way up to n minus 1 width. Do you see? Because you want the left endpoint, n minus 1 width. Cool. You don't even have to have this h hang out. You can just call that h times, because you can factor it, right? That's a constant. The sum of k to 0, n minus 1, f of A plus kh. Easy. And this is all you need for the left Riemann. For your right Riemann, you want A is equal to, you want the right endpoint, right? So starting at the 0th endpoint, right? You want to start the first endpoint. So instead you have it as h times the sum of k equals 1 all the way up to n of f of A plus still kh. The only difference is here. And that's it. Yeah, that's it. That's Riemann sums. So I'll have some worksheets up for you to do. Thank you for your attention and have a good one. Thank you.